top view. From here, draw the horizontals. Now mark the intersection points. P2, Q2, R2. Similarly, this point becomes A2, B2, C2. So when you are going to be seen from here, this top base is completely visible, right? So when your axis is tilted like this, when you are supposed to see from the top, this base is completely visible. So it is solid. That means I just join those points with the solid lines. Next, what is the farthest point from the observer from here? QR is going to be the farthest point. Okay. So let us see when your solid is going to be tilted in this manner. Let us see what is going to be happening. So when you are supposed to see the top view, which points are visible? Let us see. Only they. So this ABC is completely visible. Okay, and the corners which are going to be, this corner is going to be visible. Okay, ABC, and so this corner is going to be, P point is visible. So PA line is going to be the solid line. Okay, and when I'm going to see here, these corners are going to be, so only this edge which is going to be invisible and remaining all are going to be visible. Okay, students, my principle is generally Q, farthest point is QR, the lines which are passing from QR are going to be the dotted. But yes, but when I am supposed to see in this pattern, let us see if your solid is going to be inclined like this, when you are going to be seeing this pattern, if it is in top view, I just see these three top bases, that's okay. And I am supposed to see this corner also, this P point. So P to Q and P to R also going to be visible. Only invisible are nothing but this bottom base. This is QR only. Okay, and top view I am going to see, I am see the visible edges, solid edges also which are passing from, so that is CR and BQ also. For that only it is going to be the solid lines. Next one is, this was step 4 and stage 2. Next one is the edge which is resting on the ground, that is nothing but your R2 Q2 is to be tilted for the given inclination of 60 degrees to the VP. So draw a line of 60 degrees such that RQ is going to be on the So draw a line of 60 degrees. So VP inclination comes below XY line. So I just draw a line of 60 degrees such that your QR is going to be on the, so this was your R and this was your Q. And you know that this QR and PA are going to be perpendicular to each other. So I just draw the line of perpendicular. Okay. So this becomes your P and this becomes your A. So your XY, so you just construct in such a way that if I construct it, this line is crossing the XY line, it should not to be done. So I just had to take some inclination, which is inclination is wrong. Just go for, so if you have the space that it is permissible, then we can go for change of position method also. If you simply extend this and draw a line of 60 degrees, this becomes your new reference line x1, y1, and you can draw the perpendiculars from all the points and take the distances from old reference line and place here. This is auxiliary. So, but here the space is not permittable. So I just had to go here itself only. I just to make it a small figure. So this becomes your P. A. C. B. Okay. So it is tilted in such a way that this RQ comes on 60 degrees line. Next, simply draw the vertical projectors from here. and draw the horizontals from the previous front view. Now mark the intersection points. E dash, Q dash, R dash, A dash, B dash, C dash, O dash, O2 dash. Okay. Now simply see when your observer is going to be seen in this pattern. So that means when your axis is going to be inclined like this. So when I am supposed to see from the top, okay, it is going to be obtained. When you are supposed to see from the front, this is visible. Okay. And let us see the farthest point from the observer is C. So the lines which are passing from C are going to be dotted. Okay. A dash with P dash, P with Q, and C with R. Okay. So this becomes your sixth step. So this is change of position method. So this is auxiliary. Students, is it clear? And somewhere you place your axis also. Your black axis will come at here somewhere. You will meet at here. So this is your axis. So, a simple problem. There is no any difficulty in this problem. Simple position, face is tilted, and obtain top view. Once you obtain your top view, so it is edge which is resting on the ground. This is RQ is going to be tilted for 60 degrees. So draw a line of 60 degrees. Reconstruct the figure. Yes, reconstruct the figure such that RQ on the 60 degrees line and reconstruct the total figure. And I draw the verticals from here. Draw the horizontals. And let us take the farthest point from the observer is C. Lines which are passing from C are going to be dotted and remaining all of solid. Make it fast. Can I raise it? Anyone having any doubt in this problem? If not, I will go to the next problem. I just give you another 2 minutes. You just make it copy, 2 minutes. Okay, so we move to the next problem. Okay, write a problem. A pentagonal pyramid base side 25 mm, and axis 50 mm long, has one of its triangular faces in VP. One of its triangular faces in VP, and the edge of the base containing by that face makes an angle of 30 degrees with the HP. Draw its projections. So this was the problem. Try to understand the problem, read the given data, try to understand the problem. Let us imagine how it is to be. Let us go for assumption. A pentagonal pyramid, base shape is pentagon, you can say pentagonal pyramid. Side 25 mm, that is base side is 25 mm, axis 50, height of the axis is 50, has one of its triangular faces on VP. One of its triangular face on VP. And the edge of the base containing that face, let us consider one of the triangular face, okay, on VP. So you just have the doubt cell. So why don't we just directly take and you just put your one of the triangular face on like this. If you consider the face is going to be in this parallel to this face is going to be touch the VP, okay. So that means how can you put your simple position? If your axis is perpendicular to VP, then you can make your axis is to be inclined either in this manner, and you put your solid like this. If you are not able to put your solid touching the triangular face like this, why? Because directly we can't be able to place it somewhere at here. So first of all, we just assume your axis is perpendicular to VP. Once it is perpendicular to VP, you just rotate either in this way or in this way, in such a way that one of the triangular face comes on the VP, like this. Okay. Then only it is possible such a way that the edge containing this triangular face is to be make inclination like this. Inclination with HP in the third stage. Okay, this edge. For that only we just assume. So here axis inclination is given. No, axis inclination is not given, but triangular face is on BP. So that means let us assume your axis is perpendicular to HP such that it is tilted in a manner that the triangular face is going to be comes on VP. So when it is the position means the axis is inclined to vertical plane. Okay. So further only in simple position we place our axis perpendicular to VP. So front view gives the true shape, top view gives the triangle. Okay. So this is a pyramid. You just see all the corners are going to be joined with the apex. So this is O1 dash of O2 dash. Height of the axis is given. What is the height of the axis? The side is given as 25. So when you are supposed to see from the top, which points are visible? A, E, D points are visible, B, C are invisible. Okay. So when your base is going to be on VP means while you are seeing the top view, the base points are going to be obtained on XY and apex point is going to be on 50 line. Okay. So this is O1, this is O2. Okay. So OA is A, E, D are visible corners. So the apex to this becomes your, this is A1. So this is E1 of B1 and it is B1 of C1. So these are all with a dash. This was front view. Okay. Okay. So this was step 1. This was step 2. And this was stage 1. Next we know that the triangular face is going to be on VP. Let us see what is our triangular face. This ODC is going to be your triangular face. So that is OD1 of C1. This becomes your triangular face. This triangular face is going to be obtained on XY. Is it right or not? So we just place our simple position. First of all, it should be like this. Okay. After that, I just place my one of the triangular face. This is your triangular face is to be on VP. Okay. Is to be on VP. I just reconstructing the figure such a way that this OD is going to be on. So this becomes your O1 and this becomes your D2. And I know that ODA is a triangle. So O as center, OA as radius. Draw an arc. D as center, D as radius. Cut the arc. You will obtain this triangle. And you just place your points. So this is O2 and this is E2 and this is A2. Okay, I just reconstructed the figure such a way that, okay, so this becomes that is ODC is a triangular face which is going to be obtained on the reference line XY. Okay, this ODC is your triangle, right? Triangular face. So while it is supposed to see the top view, it becomes like this line. Okay, so why? Because the C1 is going to be not visible. So if it is going to be, it is going to be considered, then it is a triangular face. So this triangular face is comes on XY. So this was step 3. This was stage 2. Next, highest are the vertical projectors from the top view. And horizontals from the previous front view. Now mark the intersection points. So this becomes C2 dash, C2 dash, O2 dash. This is E2 dash. This is E2 dash. And it is A2 dash. Okay, and this becomes O1 dash. So when you are supposed to see from the front, this base is completely visible. Okay, so I just join all the okay. Now I just know the join the corners to the apex. Here no problem. Here also no problem. Here also no problem. But when I am supposed to go from here, it is to be the dotted. From here also it is. Why? Because no two solid lines can cross each other. So up to here the axis is visible. Remaining it is covered by the OA solid line. So this becomes your step 4. Once you obtain your front view, the stage 2 is going to be completed. Next he just gives that edge of the base containing that face. Edge of the base containing that face is making an angle of 30 degrees. What is that? What is the edge of that face containing that edge means? Let us see. ODC is the triangular face which is going to be on the VP, right? Now you can easily understand from this figure. That means, so here the triangular face is going to be on VP like this. When you are supposed to see the front, you see these three edges only. Backside two slant edges which are not to be seen. Those two slant edges are OD and OC. Why? Because ODC triangular face on the ground, OD on the vertical plane. Okay, for that only it is to be not seen. Next, so this the edge of the base containing that face means this was the face. Edge of the face containing is nothing but the edge is DC. This edge is going to be tilted for an angle of 30 degrees with the HP. That means you are supposed to reconstruct the figure such a way that it should be this edge is to be on 30 degrees line. This edge, that is D dash, C dash is to be on 30 degrees line. So that is simply I just reconstruct the figure. Let us see. Or you can extend this edge. If your space is going to be permittable, you can go for extension of this. and you can draw the two reference line x1, y1, and from here you can draw the projectors also. Then you will obtain your fifth step at here, step 5. Okay, so this becomes, if it is final front view, this fifth becomes your final top view in auxiliary. Okay, that is in auxiliary. Student, is it clear up to now? Up to now, is it clear? Students, anyone respond? Is it clear up to here? Now you simply draw the line of 30 degrees. Okay, and reconstruct the figure in such a way that DC is going to be on your, so this becomes your D dash, C dash, and from the center you can see this. So you draw the perpendicular, then you can obtain your O dash, and at somewhere at point at here you will obtain A dash. And you simply take your D dash, E dash as radius, prana, A dash, E dash as radius, cut this up. Similarly, C dash, B dash as radius, prana. Similarly, A dash, B dash as radius, prana. You will obtain your points. This becomes your B dash, C dash, D dash, and it is E dash. Now join the points. So that becomes your step 5. This becomes your step 5 in change of position method. So this becomes my final front view at here. This is your final front view in change of position method. So this is your 4 and 5 are nothing but your, this is auxiliary method. Okay, students. Now, once you obtain your final front view, you require your top view. You just draw the vertical projectors from the obtained front view. Okay, and draw the horizontals from the previous top view. And mark the intersection points. So this is C, and next it is E, becomes B, and it is A. Okay, and it is your O1, O2. Okay, so simply I just take my condition when the observer is going to be seen from this direction for top view. I just know what is the farthest point is going to be considered as D dash. So the lines which are passing from P are going to be dotted. Okay, so I just do that. So D to C, CB, A. Okay, and here it is going to be your D, it is D here. Okay, and join the all the corners to the apex. So this is your apex O, no problem. A with O, no problem, and with the D also no problem. So D is also comes to here. Okay, so this becomes your sixth step, and this becomes your stage 3. So simply let us see when it is going to be on the ground, okay, and it is going to be the edge which is going to be tilted for an angle of 60 degrees like this. So while you are going to see from the front, you are going to see all the corners, or only edge which is going to be from the front is going to be seen, so that tilted like this. So when I am supposed to see the front view, this base is completely visible. See, students, let us see. If it is going to be like this, and the edge of the base containing the triangular face on VP is tilted like this. If it is tilted like this, when I am supposed to see the front view, this bottom base is completely visible. So for that only, this is also going to be, bottom base is completely visible like this. So I am going to see 1, 2, 3, 4 corners. 4 slanted 1, 2, 3, 4, and DO is going to be the which is going to be joined at here. Yes, like this. Simplify like this. Okay. Students, is it clear? So I didn't do nothing here, students. You simply let us see. I just reconstruct the figure for 30 degrees, such a way that DC is going to be on the 30 degrees line, and I just reconstruct the figure. Once I know if DC, I get the remaining all the points. Okay. So that is fifth step. When I am supposed to draw the vertical projectors from here, horizontals from here, you will obtain the points. So let us see when you are going to be see from the front. Okay. When you are supposed to see from the top, this was your front view like this. Front view is going to be like this. And when I am supposed to see from the top, okay, I am supposed to see all the, let us see if I am supposed to see in this pattern. So that is actually the triangular face is to be on VP, okay, and the edge which is going to be here, it is going to be tilted for 60. If it is going to be in this pattern, when I am supposed to see from the top, I am supposed to see which is going to be having only one of the triangular faces on VP is not visible, remaining all the edges are going to be visible. So for that only, I just go for this, all are going to be my solid lines. For that only, I just join all the corners. And DC is going to be the and D is going to be not to be visible when I am seeing from the top.
గట్టి పని చేసి అవును.
So you can also refer this problem in problem 13.20, which is a solved example. (13.20) in the textbook, that you can easily understand now. That problem 13.20, which is a solved example. Problem 13.20 in NDB textbook. If you go for auxiliary method, then you can easily understand. Let us see how you are going to obtain this solid outline, sir. So if it is auxiliary method, let us see your fourth and fifth and final step. This is your final front view. If you go for auxiliary method x1, y1, so always your observer is also going to be perpendicular to the new reference line x1, y1. When observer is supposed to see this solid, then you are going to see all the base is completely visible. So that only it is going to be A, B, C, D is going to be the solid line. So I just join all the points are going to be with the solid line. So when I am supposed to join all the corners, okay, so then I am going to obtain only obstacle as, so DE is going to be the dotted, remaining all are going to be the solid lines. Okay, students. If you easily understand how can we obtain this future, simply you just see in this pattern if it is going to be observe the method. So fifth step is going to be obtained, the observer position is going to be in this manner. So base is completely visible. For that only my base is also completely visible as a solid line. So which is going to be not to be seen is nothing but your this D slant edge, D base edge is going to be, D base edge is going to be not to be seen from there. So for that only the DE becomes your dotted line. Okay students, is it clear now? I just give you 2 minutes, all of you make it fast. Student, just make you clear one more point. So if your farthest point from the observer is going to be, what is the point? D. Simply let us consider points which are going to pass in from D are dotted. Let us see. If D is going to be, D to C is a dotted line actually, you know that. But when I am supposed to join C with O, C with O, that means corner, base corner to the base corner C point to the apex, this dotted line is going to be covered. You just, it is, so DC is a dotted line which is already existed, but it is hidden by the CO slantage. CO slantage. Okay. So similarly, if I join D with O also, if I join D with O also, this is also dotted line, but this is also covered by the CO solid line. Okay, I just write this point. Let us see. So D comma C, D comma E are the, and O1 comma D are dotted lines generally. But main you just had to see this as, so E comma C and O1 comma D dotted lines are hid by the O1 comma C slantage. So this you just had to remember. Okay, so DC and OD, these are going to be hidden by the this OC solid line. Student, is it clear now? So how it is going to be obtained? Only D is going to be dotted. Okay, students, is it clear now? Student, is it okay? Can I erase this problem? Shall we move to the next problem? Okay. Write a problem. Draw the projections of a cylinder. Base diameter 30 mm and height of axis is 50 mm. Height of the axis is 50 mm. Rest with a point. Rest with a point of its base circle on HP such that the axis is making an angle of making angle of 30 degrees with HP. Axis making an angle of 30 degrees with HP, and its top view is perpendicular to VP, and its top view is perpendicular to VP. So we are supposed to draw the projections of this problem. So draw the projections of the cylinder of base diameter 30 mm, cylinder base diameter 30 mm, and height of the axis is given 50 mm long, rest with a point of its base circle on HP such that axis is making 30 degrees to HP, and top view is perpendicular to VP. Such a simple problem. We already do the simple position. We know the simple position. We know stage 1 and stage 2. Only stage 3 is we are supposed to see in this problem. Cylinder diameter 30 and height is 50, resting with one of its base on HP on one of the point on the base circle, and making axis is 30 degrees to HP. So this was the first and second stages. That is, first stage is axis inclined to HP, means put your axis perpendicular to HP, top view gives the true shape. This was stage 1. Stage 2 is axis inclination to the given reference plane, which is 30 degrees to HP. So that this was stage 2. What is stage 3? And its top view is perpendicular to VP. So if you put your axis inclined to HP like this, you obtain your front view and top view. That is, your fourth step is going to be tilted for 90 degrees. That means your final top view is to be constructed for tilting the obtained fourth step for 90 degrees. Let us see. XY. So if axis is making 30 degrees with HP, means axis perpendicular to HP, top view gives the true shape. Okay, so divide your circle into 8 number of equal divisions for my convenience. Mark these points as A1, B1, C1, D1, E1, F1, G1, and H1. So this is a cylinder. You are having two bases, top and bottom. So top is going to be visible and bottom is invisible. So the points are P1, Q1, R1, S1, T1, U1, V1, and W1. So this becomes your O1 of O2. Height of the axis is given as, so given the diameter is step 1, stage 1. So when you are going to be seeing this pattern, so A, B, C, D, E are visible. So height of the axis is given as, how much height is given as? 50. Okay. For cylinder, you are going to see only you are going to see only visible solid outline, and remaining are only for our reference. Those are only the referral points. We already do the problem of cylinder in yesterday and previous class. Okay. So these points becomes A1 dash, B1 dash of H1 dash. This is C1 dash of G1 dash, D1 dash, F1 dash, and it is E1 dash. Similarly, the points are at here. It is P1 dash, Q1 of Q1 dash of W1 dash. Next, R1 dash of V1 dash. Next, S1 dash of U1 dash, and next this is T1 dash. This is O1 dash, this is O2 dash. Okay, so this was step 2. Once you obtain your step 2, next we know that rest with a point on its base circle. Rest with a point on its base circle, let us consider that point is this T. Rest with a point on its base circle. Okay, and then the axis is going to be inclined for an angle of 30 degrees with HP. So draw a line of 30 degrees with HP. Such that okay, now mark the points. For cylinder, you just highlight only the solid outline. So here its inclination is given as 30 degrees. The points are A2 dash, B2 dash of H2 dash, C2 dash of G2 dash, D2 dash of F2 dash, and E2 dash. Now this point is T2 dash, S2 dash of U2 dash, is R2 dash of V2 dash, this is P2 dash, Q2 dash of W2 dash. Okay, the point with a point on its base circle, so this was that point. Okay, now draw the, this was step 3. And draw the horizontals from the previous top view. Now mark the intersection points. Mark the intersection points. P, Q, R, S, T, U, V, W. Similarly, the points are A, B, C, D, E, F, G, H. So when you are supposed to see from the top, so this top base is completely visible. So I am going to obtain okay. So farthest point is T, and this is a cylinder. I just join only the end generators. This is O2 dash, O1 dash, O1, O2. So this becomes my step 4. Okay. Now I go for the next. The top view is perpendicular to VP. When your top view is perpendicular to VP, so this was the top view. So it is actually, this top view is parallel to VP. Now you just make it tilt for 90 degrees. Okay, if you make it tilt for 90 degrees, that is like this. If your cylinder comes like this, again the reconstruction is going to be done. Make vertical and draw the horizontal. That becomes your change of position method. For my convenience, I just go for auxiliary method. So auxiliary method means how it is going to be perpendicular. If I draw the line which is perpendicular to xy, this becomes my x1, y1. So this becomes my final top view in auxiliary method. And if I draw the line perpendicular to xy, that means apart from tilting for 90 degrees and reconstructing, I just draw new reference line x1, y1 which is perpendicular to xy, a line drawn. Now this becomes perpendicular to VP. Now I just draw the perpendiculars from all the points to the new reference line. I just extend these projectors. Now I just place it from the new reference line. I just require my final front view. Why? Because the fourth step is already in top view position. It becomes my final top view. My requirement is final front view. How can you obtain my final front view? From auxiliary method, let us take the distances of all the points from the old reference line and put it from the new reference line on their projectors. Let us see PQ, RS, TU, W. Let us see. P is going to be the farthest point from here. So this becomes your P dash. Next, with this radius Q and W. So this is Q dash, W dash, and at the center it is going to be RV. So this is V dash, R dash, and next it is U and S. U dash is S dash, and T dash is the point on XY itself. So this T point comes on XY. Now similarly put your points of A, B, C, D, E. A dash, B dash and H dash. Next one is C dash and D dash. C dash. This becomes G dash. And from here D dash and F dash. F dash. And this is D dash. And finally E dash. So this becomes E dash. So when your observer is going to be, for new reference line means observer position is always perpendicular to the new reference line. Observer is going to be watching in this manner. So then which base is completely visible? PQRS UVW is going to be completely visible. So this was completely visible. Okay. And when you are supposed to see the farthest point is going to be E. Farthest point from the observer is E. Lines which are passing from E are going to be the dotted lines. And I am supposed to join only the end generators. And this becomes your O1 dash, O2 dash. So this becomes your final fifth step in auxiliary method. So what you can do if it is a change of position method means directly you reconstruct the fourth step in such a way that your axis is perpendicular to XY. That means treated for 90 degrees and reconstruct the figure and draw the vertical projectors from here, draw the horizontals from here, you will obtain another cylinder. Okay students, is it clear? Is it clear for you? Okay, all of you write a problem. I just dictate you a problem, take it as assignment, as similar as like this problem, previous problem. That is one of the axis is going to be inclined to VP, axis inclined to VP. So front view gives the true shape. That is all of you write a problem. A cone, draw the projections of a cone. Draw the projections of a cone of base 30 mm, of base diameter 30 mm, base diameter 30 mm, and height of the solid is 50 mm. Height of the solid or axis height means the same. Okay. Touches the VP touches the VP on a point of its base, touches the VP on a point of its base, touches the VP on a point of its base circle with its axis inclined, with its axis inclined 30 degrees to VP, 30 degrees to VP, and front view of the axis is inclined, front view of the axis is inclined 45 degrees to the HP. Front view of the axis inclined 45 degrees to the HP. Okay. All of you do that problem. I just once again point out the problems which you are supposed to see, these all examples in NDB textbook. Problem 13.12, 13.13, and 13.18, 13.19, 13.20, 13.21, 13.2, 13.2b, 13.25, 13.31, and 13.32, and 13.32. All these problems are solved examples which are discussed by in our sessions also. We discuss the same kind of problems and some of the same problems also. So if you have any textbook also, you just go through these solved examples, okay, and also do the problem which I given as assignment, okay. So that is going to be the, we just stop the session and the topic is completed as a projection of solids. So in tomorrow's class we will see the sections of solids. Tomorrow class we will see the sections of solids. Okay, all of you kindly go through the problems which we discussed so far in the projection of solids. Once you have a clear idea about these problems, then it should be easy in the sections of solids. Okay, I request you once again, all of you kindly go through the problems which we discussed so far. Okay, and tomorrow's class we will go for the sections of solids.
Question repeat sir.
So okay.